This is a Shore D gauge tester. It goes from 1 to 100 on the dial. This little dial right here is the red line in the background that stays where the reading was. So if you set that down to 0 and you do a hardness test, it's going to move. So I pressed it on something and you can see the red line moved and it's at 81. This has a large foot. That foot has to sit flat, which is difficult to do if you're on an uneven area that looks like that. The bigger the foot, the harder it is to get just the resin for a composite. Remember, this is designed for flat surfaces, not curved surfaces. This is another style of Shore D gauge. You can see this one also goes from 1 to 100, and it has the little dial that gets left where you leave it. But on this one, the foot is much smaller, and that needle can find something with a flat surface much easier on a curved surface than that big foot. So I recommend if you're going to use a Shore D gauge, use one like this and do it on the highest point of resin. These are Shore D calibration blocks. This one right here is rubber. You can see I can bend it. That's rubber, and they're flat. This one's plastic. Right? I can't bend it, it's plastic. It's hardened plastic, and it's flat. This is what it's designed for, not for pipe and coatings the way we use it. However, it is suitable to determine some of the factors that are necessary to determine cure on a pipeline. And today we're going to go over how to use a Shore D gauge, one of these guys right here, to measure a product like Bore-Wrap. Bore-Wrap is a moisture-cured urethane on a fiberglass structure. The reason we're going over this is because many people don't properly utilize Shore D. We use Shore D in this instance because most of the time people are interested in how quickly they can install the product. When you're dealing with Bore-Wrap, you have to reach a certain level of hardness to ensure that it is cured far enough that you can pull it in. This is a hard rubber right here, and this is a plastic. They're both flat, and that is the intention of a Shore D gauge. You press it in, and this one measured about 22 on the Shore D gauge. So you can see the little red tab. On this one, press in, went a lot farther, and it measured about 80, 81. This one does the same thing. Press it down, let me reset it, press in. This one measured about 20, 21. Set it on here. Again, this one measured, this time I got about 76. Now it's back at 80. So how you hold it and how big the foot is makes a difference. This has a very small foot and a very small indenter. This one has a rather large foot and the same size indenter. When you're working with flat surfaces, the size of the foot doesn't matter terribly much. Now, Bore-Wrap is obviously not a flat surface, but on a curved surface, it's a little bit harder to take a reading. And if the curved surface is uneven and it's wavy, it's definitely harder to take it. Here's a flat panel of Bore-Wrap, right? This was made specially for testing, but on here, I press this down and I have a Shore D of 80. Okay, if I come over on this side and I find a spot that maybe is a little bit lower and the indenter falls into that spot, let me reset this. The indenter falls into that spot and I press it, I got 62. It's the same piece. Now if I move it over here, I'm back to a flat surface, I'm at about 77. So this is a very flat, uniform surface, but right here, you can see there's a little bit of a divot. And if that needle falls into that divot, it measures differently. When the surface of Bore-Wrap is cured, you have variations because it has a bunch of different fibers in all different orientation. You can see there's some creases on there. You can see there's some foaminess. I'm gonna take this foamy piece, I'm gonna set it down, and I'm gonna move it around until it sits. Press down, and that one has a 60. Because it fell in between the fibers and the grooves. Now, if I find the highest peak where there's a lot of resin and I set it on there and I press down, now I'm at 70. If I flip it over to where there's a lot of resin and I press into the resin, now I'm at 85. And this is the same piece, it's been cured the same way. It's just a matter of where the fiber orientation is. So you have to make sure that you find the highest point of the resin so that you take that on the reading on the resin, not on the fibers. This is a piece of carbon fiber. Fiberglass is the same. When you take a reading on these kinds of fibers, the indenter could fall in anywhere. This one measured a 30, but it has the same resin as the Bore-Wrap on it. The problem is, there's so many different ridges in this fiber that it falls into those ridges and you're measuring a valley, not the resin. here's the thing. When you cure out a moisture cured urethane that's a composite, the fiberglass is not curing. Fiberglass is already cured. You don't have to cure fiberglass, but it's going to move around from the indenture. You can't take a short D reading on a piece of fiberglass. What you're truly testing is how far has the resin cured, and you can only do that if you're on the resin, okay? This piece, you can see, it's fully cured. It's been fully cured for probably a year. It's been sitting in my shop. This piece never had any water added to it. None. Zero water. It was left on the floor after we finished a Bore-Wrap installation, and I picked it up the next day, and it was solid as a rock. You're not checking whether or not the resin is mixed properly to achieve full cure. What you're checking is to find out, did it cure enough to be hard enough to be used at that moment? If enough time has passed and the conditions were good when you applied it, say it was over 60 degrees and it's been 24 hours, that product's going to be cured. There's almost no reason at all to test it unless when you touch it, it's tacky. If that's the case, then you didn't have enough water applied to it. But if you wait long enough, without water, it will harden. When I say it will harden, I'm going to show you a little demonstration. Here's a piece of wood. Here's a nail. Here's Bore-Wrap that was cured without water. I can nail this through. It does almost no damage to the Bore-Wrap. And pull this out. Do it again. This never had water added to it. It's 100% cured. Bore-Wrap will pull moisture from the air to finish its cure. So when you are checking Shore D, if it's hard, chances are it's cured, because the only way you can not cure is if you're inhibiting the cure. The only way to inhibit the cure is you keep moisture from it, which there's moisture in the air, so it has to be in a sealed package, or you have it so cold that the water can't react with the resin. That's it. But to give you an idea, if I do this, and I have wavy coating, right? And I try to take a reading right here, well, I get zero, because I'm measuring between the fibers. If I go here, I get a 75, which is perfectly good. If I go over here, I get a 78. But if I go in the middle, I'm pressing down hard, but the pin is not indenting, so it can't come back into the body to give you a reading. With this, you'll be able to see the various ways that you can use it. Again, I remember I said for an oval surface, I recommend a Shore D gauge that has a much smaller end. So as I said, the Shore D gauge is suitable for hard plastics. This is HDPE, so I should be able to get a reading on this. I'm going to reset my gauge. I'm going to find a spot that's smooth, and I'm going to set it down and make sure I've got a good reading. It gave me a reading of about 63. Okay, that's not bad. This is an epoxy. This epoxy is fairly smooth, but it does have uneven surfaces. So I could try to do those uneven surfaces, and I'm going to get weird numbers. In fact, I'm going to try to do that right now. So I'm reset it back to 0. I'm going to get over where those weird surfaces are, and I'm going to press down, and I got a 50. That's because it's uneven right here. Now, if I do the same thing, and I move it over to where it's smooth, and I press down, now it's an 86, which is where it should be. That's for the epoxy. Bore-Wrap can be used once it's over 65 Shore D, but that's not the ultimate Shore D. The ultimate Shore D is about an 80. So if I take this measurement, I reset it, and I put it on here, and I just willy-nilly choose something, and I press down, I got a 64, which on the books is not cured. But this is years old. Years. It's been fully cured for a long time. The problem is there's grooves from where the compression film set in, where there's different layer counts, different things like that. So if I am strategic and I find a high point and I press it in on the high point, now I've got 79. Now, just like here, if I were to go like this, it's flat, but it dipped into the hole. These are holes. All these grooves, that's a place for their little needle to fall into. You want to make sure you're not in one of those grooves. If you're in one of those grooves, your number's going to be low. I'm just going to move around until I'm in a groove. I'm in a groove. I sit down, see what I get. Well, lucky I got 71, but that's not always the case. I had 64 earlier, and this is a fully cured piece, and it's very smooth. Over here, I'm going to find one of these older grooves, press in, and I got 72, right? But if I move it over a little bit to the high point, press down right there on that high point, and now I'm at an 83. So keep that in mind. For a curved surface, you want a smaller foot so you can get as flat as possible on it. You want to make sure you're not on a low area. Now on this uneven spot, I could fit that needle right on the top of an uneven spot, and I'm going to get a high number. Look at that, 87, 88, something like that. That's what the hardness is of this epoxy. But that's because I was on the high point, not on the low point. If it's on the low point and I press in, I'm only going to get maybe 60, okay? That's not the Shore D of this. That's why you want to take take multiple readings to make sure that you got the right reading. And this is not going to cure in an uneven way.